So here on this first example here, okay, you have a base 3 and a base 8. And there's no way that you can rewrite those so they're in the same base. So what you need to do is you need to take the log of both sides. So if I take the ln of 3 to the 9x minus 2 and ln of 8 to the x, we can now use the properties of logs to solve these the resulting equation. And the property we use is any expressions in the power of a log, in the input of a log, can be moved out front. So we move this, we get 9x minus 2 times ln 3. Here we move the x out front, x ln 8. And then we work as we would an algebraic equation here. So we can distribute. The ln of 3 is just a number. It's an irrational number, but it's a number, so we can distribute it. We get 9x times ln 3 minus 2 ln 3 equals x ln 8. And now when we're solving this equation for x, we need to put all of our like terms together. So I need to move the two terms with x on the same side. So I'll leave this here. I'll subtract x ln 8 from both sides, and I'm going to move my constant over to the other side, add 2 ln 3. Because I want to isolate my x eventually, and the way I can do that is to remove it as a common factor. So if I take out an x, leaving 9 ln 3 minus ln 8. Again, I just factored an x out of both those terms, and now I can isolate it completely by dividing both sides. And so this right here is my exact answer. If I entered this in my answer space, it would show up as green. It would be correct. Now, it does say round to 4 decimal places, so if you put this into decimal form, you can take 2 ln 3 and divide by the entire quantity, 9 ln 3 minus ln 8. I'll put a decimal in here so my answer is displayed as a decimal. Close off my parentheses from the denominator. And when I do that, I get my decimal equivalent, which is 0.2814 approximately for my solution. All right, let's see how this compares to the next problem. Okay, same idea, base 2, base negative 9, or base 9 with a negative in front. Okay, you can't express those using the same base, so I'm going to take the ln of both sides. So ln of 2 to the 3x minus 6, and ln of negative 9 to the x. Okay, now, before I go any further, I notice one thing here, and it's something that students probably don't pay that careful attention to, or it's not something that's necessarily emphasized overly. But when you are working with logs, the base of a log has to be a positive number, right? It can't be 0 and it can't be a negative. And same with the input of a log. The input of a log cannot be a negative number or a 0. And so when we look right here, is there any way that we're ever going to even be able to take the log of negative 9? No, it's not going to work. So if you get to the point where you see that, you know that it's not possible. Okay, so this is a solution that does not exist. If you entered this in your calculator, if you did the solve feature here and hit enter, it would say false. Remember, false means no solution. Right? And so this solution does not exist. Right? So for this particular problem here, base 7, base 8, there's no way to rewrite either one so that they have the exact same base. So we're going to take the log of both sides. Okay? Now, for this example, I'm going to show you with the common log. Okay? You can choose either one. Okay? So let's say I take the common log of both sides. So log of 7x is equal to log of 8 to the minus 9x minus 3. Okay? We then use the properties of logs, move your powers out front. You get x log 7 and negative 9x minus 3 times log 8. Okay? We need to distribute our log 8. So we get negative 9x log 8 minus 3 log 8. Okay, and now we take our two terms with x's, and we need to make sure they're on the same side. So I'm going to move this over and add to both sides. So x log 7 plus 9x log 8. That's equal to negative log 8. And now I can remove my common factor of x, leaving log 7 plus 9 log 8. And finally, divide both sides to isolate my x completely. Okay, and that is my solution. Here's the exact answer. If I want to find the decimal equivalent, I can calculate it. Here, negative 3. Oops. Log 8 divided by the entire quantity, log 7 plus 9 log 8. Close that off. And I'm going to put a diamond so that my answer is displayed in decimal form. I get negative 0.3019. And so that would be the decimal equivalent. If you used ln's instead of logs, you're going to come up with the same number.